Hello, welcome to the Extraordinaire. In today's episode, we are going to be looking at some data structures. Before we go into the data structures that we're going to be looking at for today, which are stacks and queues, let's go over some methods on lists. So we'll create a new file here. Let's say example 1, and I'm going to create a list that we're going to be using in this example. I'm going to call this list footballers, and I'm going to add some names of some footballers. Let's say Haaland, Gabriel Jesus, what other footballers? Foden, we have Ederson, Gabriel Martinelli, and so on and so forth. So we have our list of footballers. Let's see how these methods can be used to modify this list. The first one that we have here is the append, and it's straightforward. The append method adds an item to the list. So if we do our example here, let's print this original list. Say original, and we print footballers. Then we will append to the footballers now. Let's append Odegaard and print for append. Now let's run this and see how it looks. Do Python 3 example 1. So we see that we have Haaland, Gabriel Jesus, Foden, Ederson, and Gabriel Martinelli, but after we appended, we have Odegaard at the end. That's what our append method helps us to do to the list, to add items to the list. Let's see some more methods. Now for the next one, we have extend. Basically what that does is to allow us to add another list to the end of the list. So let's say we have an extension list here, some more footballers. We're going to say Saka, we're going to say Maguire. Who else do we have here? I'm running blank. Cole Palmer. Then let's append. Now let's extend this list. So say footballers, extend, and then we add our extension. Now if we print for the extend method, footballers, we would have the list that includes the original list and our extensions. So now we have Saka, Maguire, and Cole Palmer added to the list. The next method we have is the insert. The insert method accepts two arguments. The first argument is the index, where we would want to insert the item, and then the second argument is the item itself that we would want to insert. So for example, we have our footballers list. let's say we want to insert at the very beginning, so we'll say 0, and we want to add JZ. I know JZ is not a footballer, but there's a reason why I'm adding this. So if we add JZ at the beginning of the list, we see that JZ, hold on, no, we didn't print this, so let's print insert. Now we should see JZ at the very beginning of the list. The next method that we have is remove. Now you see why I added JZ. That's because we want to remove JZ with this next method. So if we say footballers dot remove and I say JZ, I am using lowercase z here. This will not work, but let's try it out and see. So then we print remove and footballers. This is going to throw an error. Why? Because it cannot find, you see, we have an error. It can't find this exact item. So when we are removing, it has to match, whatever we are removing has to match an exact item in the list. So let's update this now to the correct value and run it again. So now we see JZ is no longer in the list when we remove. The next one that we have is pop. So if we pop from the list, is like remove, but the difference is that it is being removed from the end of the list, and we could also specify an optional index if we like. So let's see what we have. Also, for the pop, it returns the value that was popped. Let's look at it. The first thing that we do is we pop the footballers list, and then we'll print for pop. So when we pop, notice that Cole Palmer has been popped off the list, but this value can be assigned to a variable. Let's say, for example, pop value, and we can use it somewhere else. Let's just print it here, pop value. Now we should see the value that was popped. So you see, pop value is Cole Palmer. So for some methods like pop gives us the value that was popped. There are other methods like this that returns a value, and we'll see them as we continue. The next method that we are looking at is the clear method. What this does is it basically wipes off the list. So let's take an example. If we say footballers clear, and then we print for clear the footballers list, it would be an empty list. Yeah, clear shows us an empty list. So that's what it does. It empties the list for us. Let's redefine this list again. The next method we have is the index. So the index method tells us the index of a particular element in our list. So for example, we want to see what is the index of fooding in our list. So we'll say index value is equal to footballers, and we say food, and we print index value. Index value. Okay, hold on. What's the error here? This object is not callable. Oh, sorry. This is supposed to be index. Now let's try this again. Yeah, so index, it tells us that Foden is on index 2, and that's correct because this list is 0 indexed. So we start with 0, 1, 2. So Foden is at index 2. We can pass in a start argument, a start and end argument. For example, we'll have a list like this. Let's remove the last names of these players. So we have 2 Gabriels in this list. If we want, we could do something like this and say print, let's do index value 2, we'll say footballers index, and I am looking for Gabriel. If I just put in Gabriel, it would give me the index of this Gabriel. But if I do it again and I say it should start at, this is 0, 1, I say it should start at 2, it will give me this Gabriel instead. Also, this is, let's say index value 3, then index value 4. We could also do the same thing by saying 2 to 5. That's because no, we can't say 5, we say 6. In our previous episode where we were talking about lists, we talked about how to get a subsequence of a list, and how we do that is we impute the start value and then we impute one more than the value that where we want to stop. So in this case we have 0, 1, 2, 3, 4. Okay, so we are going to stop at 5. So this is 0, 1, 2, 3, 4. Then we'll stop at 5. Why? Because 5, the last index is not going to be included. So let's print it. These 2 index value 3 and index value 4 are equivalent. Okay, because we are basically saying start from 2 all the way to the end. We could specify a different index for the ending index, but remember it has to be one more than where we want to stop. So let's see how this looks. So for index value 2, what do we have? We have index value 2, index value 3, and index value 4. So this index value 3 and index value 4. Okay. So as you can see, for index value 2, it's 1 because it's this first Gabriel that it is using. Now for index value 3, it would skip the first Gabriel because we say it should start at 2, right? And it gives us 4 because that's the index of the next Gabriel that it can find in the list. So this is how we use the indexed method. I'm going to comment out all these other examples so that the screen is not filled up. Okay, much better. The next method is count. Now the count method allows us to count the number of times that an element occurs in the list. So for example, we can say count value equal to footballers dot count Gabriel, and then we can print the count value. So this is the count value is 2. That's because Gabriel appears 2 times in our list. We have for Gabriel Jesus and Gabriel Martinelli. Remember, we've removed their last names in this at this point here, so it matches for both of them. The next method that we have is sort. The sort method allows us to sort the elements in the list, so we can decide to sort them as they are, or we can pass a function that determines how they will be sorted, and we pass that function using the keyword argument. We could also pass a reverse keyword argument that tells it, which is a boolean value that tells the sort to reverse the sorting pattern. So it can either do it forward or backwards. When reverse is true, it does it backwards. When reverse is false, it does it forwards. So let's see how that looks here. For this example, we have footballers dot sort, and if we print this sort footballers, as you can see, the names of the footballers have been sorted as they are. Ederson comes before Foden, before Gabriel again, and finally Haaland. If we should say footballers sort reverse true and print this reverse sort, what we have is the reverse of what we had before, which is neat. Next, we have the reverse method, which does exactly the same thing as this reverse keyword, but now we have it as a standalone method. The advantage of having this separately is that we can specify our key for this one. For the sort method, you can specify a key here and put a function here to determine how it will be comparing each element in the list. Then for the reverse method, we just basically say reverse the list as it is. So let's say footballers reverse and print reverse sort, no, just reverse. Good. Notice what is happening here. First, we had the list sorted in ascending order, then we reversed it. Now we've reversed the reversion, so now it comes back to the way that it was before. Okay, so that's how it goes. So this is the reverse, this is the sort, this is the reverse sort, and this is reverse method. Let's continue. The last method that we have here is list, the copy method, and what it does is it copies the list. In a previous episode where we talked about list, we explained why it is necessary for us to copy the list. I don't want to go over that again in this video, so I'm going to link that in the description. So let's proceed. We're going to have football as copy, and we say footballers dot copy, and if we print footballers, we have the footballers list. We will print the footballers copy as well. We have that. So you see that they're exactly the same list. Exactly the same list. If you want to know why it is necessary for us to copy the list, you should really check out the video on lists, and you understand why this is important. Now that we've gone through all these methods, we can now start looking at the data structures that we want to look at in this episode, which are stacks and queues. A stack is a data structure that operates on the last element first. So if you have a list of items, and let's say we have item 1, item 2, item 3 would be taken care of first. Now to make more sense, let's take a look at an example. I'm going to create a new file here, and I'm going to save this as stacks.py. In Nigeria, where I reside, when you're about to graduate from secondary school, we do what is called clearance. And when you are doing clearance, you're basically going through to all the offices in the school to get their signature before you can leave finally as a graduate. So we're going to use that as an example for showing how we can use stacks in Python. For Python, we are using lists to implement stacks. So what we will do is we have our clearance steps. Here we have the first item is get principals signature. The next is get VPs, which stands for vice principals signature. The next one is get buzzers signature. And for this stack, we're going to append some items to it. So the regular append method that we have on the list helps us to implement adding items to the stack. So if we do append, it adds it to the end of the stack. We do another append, the item is added to the end of the stack. And if we want to pop, we pop from the end of the stack as well. So like we said, the last item is taken out first. And that's how the stack data structure works. So let's append some new items. So say for example, we need to also get the librarian signature. We can say clearance step append get librarians signature. And let's say you've been a very naughty student and you borrowed a book but you did not return it. You will have to return the book before you can get the librarian signature. So we'll say return borrowed book. Let's see how we would operate this stack. So we can do something like this and say step equal to clearance steps dot pop, and this pops an item of the stack, and we can basically loop through this stack now. Say while step print step, we'll say if len clearance steps. So len is a function that tells us the length of our list, and since we are using the list as a stack in this case, it tells us the length of our stack. So if the length is equal to 0, we're going to say print you are cleared, and we'll break off the loop. Then we would continue to pop here if the steps are we still have some items in our stack. We'll continue to pop until we no longer have any item in the stack. Again, the first step here is we pop from the stack and hold that in the variable called step, and then we're going to loop through. Inside the loop, we're going to print the step, then we'll check if the stack is empty. If the stack is empty, we'll print you are cleared and break out of the loop. But if the stack is not empty, we'll pop from the stack again, assign it to the step, and we'll continue to loop and print the steps. So let's see how this looks. Can we see? So it starts from the end, the last item that was appended. So you return the borrowed book, get librarian signature, get bursar signature, get VP signature, get free principal signature, and then you are cleared. And that's how you would use a stack in the real world. The next data structure that we have here is the queue. A queue data structure is like the opposite of a stack. Instead of taking items at the end, it takes items out at the beginning. So while a stack is taking items at the end, which is called a last in first out data structure, a queue is first in first out. So the first item that comes in will be processed first. So let's see an example of that. We'll create a new file. Let's save this as queues.py. So let's create a list. So let's say in Python, for us to be able to work with queues, we need to use a module called DQ. We're going to import a module from the collections library called DQ, and that is what we're going to use to create our queue. So we're going to say from collections import the queue, and then we're going to create a queue. So let's say we have an orders queue. There are people ordering for food. Now it wouldn't make sense for us to attend to the last person first. It makes more sense to attend to the first person that came to the restaurant first. So let's say we have someone is ordering for jollof rice. Another person is ordering for pizza. Another person is ordering for spaghetti. So we create this by create an order queue by passing this list into the queue function like this, and so that creates our order queue. Now with this we can append more items into the queue, and if we want to take out items from the queue, we just call pop left or pop right, either depending on where we want to pop from. But for queues, it's usually you pop from the left, that is, you are taking out items from, you are taking the first item first. So let's continue with our implementation. So we have, let's say we get some new orders, order queue will append, for example, moi moi, and fish stew. Then we also have added to the queue akara and akamu. Okay, so we can process this by doing a similar thing that we did for stack, where we say order is equal to order queue dot pop left, and then while order we can print serve order, and then if len of order queue is equal to 0, we would print all done and break off the loop. So if that is not the case, then we would just continue to pop left from our order queue. Again, the first thing that we do is to pop left from the order queue. While we are having orders, we will print serve order. If the order queue is empty, then we print all done and break out of the loop. But if that is not the case, we will continue to pop left from the order queue so that we can print more orders until we are finally done. So let's see how this looks. Nice. So we serve jollof rice, which is the first item in the queue, serve pizza the second, spaghetti, moi moi and fish stew, and then we serve akara and akamu. So that's how we use lists to create stacks and queues in Python. In our next episode, we are going to be looking at list comprehensions, but for now, that's it. Thank you for watching. If you enjoyed the content, please like, subscribe, share with your friends. I'll see you in the next one. Bye.